for the ECG lab for human. And what we're going to start off with is figure 1 here, talking about how to generate our 4-second image of an ECG. So this says to only include leads 1 and 2, lead 3 is fine. Label the PQRS T waves, and then also showing how to measure the P to R interval, S to T segment, and then determining the standard deviation of measurements before and after exercise effectively. So our takeaway is that we want to be able to see what's changing here before and after exercise. So to measure these different types of things, let's go to, first let's just remind ourselves of what that's about. The PowerPoint that we have here, our P to R interval begins before the P wave and then goes until we get right before the R wave there. So that's our P to R interval. That shows when our atrial depolarization begins and then until our ventricular depolarization begins. And then our S to T segment right here is the duration of our ventricular contraction that's occurring here. So that's the how forceful or how quickly that contraction is actually occurring as we're looking at the duration between the R wave and the actual T wave. Okay, so that said, then let's go back to our term here and go back. Okay, so now we are looking at this and it's asking for us to show the P to R interval and S to T segment. So let's go to that and pull up our one of the first of the files that we have here. So I'm just going to do a moment while I move something out of the way. Okay. Whoops. All right. So I'm going to pull up the post-workout data. So this will be one of the first files that you guys would have generated. And so we see 3 different leads here. It's okay to have the 3 leads in your picture that you provide for me. I would like to see lead 1 and lead 2 at least. And then what you want to be able to show is a couple of the different cycles here. And so we can set that up. I'll just zoom in a little bit here between a couple of these and zoom between 2 markers, and now we can see those waves pretty easily. Let's go back to this for a second. P to R, S to T, and so it is. And one of the things that we're looking at is the resting ECG. So you don't actually have to do this for the exercise ECG. You just need to make the image for the resting ECG, so I know that how you actually set up this stuff and how you measured it. And you want to be really clear about that so that there's no confusion. Okay, so P to R interval and S to T segment. P to R interval. So P wave begins right here, approximately, for this guy right here, for example. And then the R interval begins right here. Alright, so did the instructions specify for a certain time period? 4-second image. Okay, let's go back for a second and see how long this image is. Looks like, let's set this, oops, here. And here, looks like we're going to have to zoom out a little bit. That's fine. Zoom out a little more. No big deal. Okay, there we go. Now we're zooming between 2 cursors, and now we've got a nice 4-second image here. Okay, P wave is right there, and the onset of the R wave is right here, so that indicates our P to R interval. So you can measure that. There's our T2 minus T1 tells us the time between the 2 cursors there. And so that tells us when the onset of ventricular atrial depolarization happened here and the onset of the ventricular depolarization here. All right, great. So what about this S to T segment? What we do is we move 1 cursor over here to the end of the R wave and that complex of the R wave, and then we move this to where we have the onset of our T wave. Well, this is a little hard to tell there, isn't it? But do the best you can, and you can look at the other waves to try to get a good idea of when that might be. Like this one down here looks a little cleaner, and you can kind of see that T wave a little better. And just try to get as close as you can to getting a decent T wave there. But this one is kind of floaty. You can look at some other ones. you'll show me how you actually do these measurements by putting in brackets, but then the other thing that you're going to also want to do is to make multiple different measurements before and after exercise. So if this is during, this is actually probably after exercise because it's relatively late, and then if I move this back to before exercise, you can see how the ECG waves are a lot further apart. It's when they're at rest, and then you can do measurements of the S to T segments and P to R intervals there. So you'll do 3 of those, and after you do those 3 in a particular image there, then what you can do is put them into an Excel spreadsheet. So I have here the Excel spreadsheet that we will use for calculating some of the other figures, but it doesn't actually show the table that they're asking for. So let's look at that table and see what they're asking for here. They say that the table that they want is wants to show, they report average and standard deviation for the instantaneous heart rate, the P to R interval, and S to T segment for pre and post exercise. So what does that look like? To put this into some kind of clarity here, what you can do is say that you want instantaneous heart rate here, P to R interval, and S to T segment here, and then you can just write pre-exercise and post-exercise, and then you can put in the numbers. So you're going to want to go through and take the averages and standard deviations, but let's pretend it's like 54 plus or minus 5, and here, then you can underline that to try to give it so it looks like a minus there. I kind of overdid it, but I'll away and okay. And then you can go ahead and complete that. Also, to make it kind of centered and look nice, you can choose to make the borders, add all borders there to do that. You can center it. You can do things like, making these, you can shade this in with a color if you so desire, and so on. So this gives you an idea of how to set up and what they're asking for out of that table they're asking you to generate. Okay, so you'll type this in and generate those things for Figure 1. So I think that helps for Figure 1. Let's move into Figure 2 and see where that takes us. So I'm going to move us back then to Figure 2, the Bainbridge reflex recording. This wants a 10-second image. It includes a single ECG channel and the breathing of deep inhalation in the middle of the trace. And then it's asking for these measurements and to put them into these different tables. And so what we're going to want to do is to measure the instantaneous heart rate for each cardiac cycle that we have within this 10-second trace. So this takes a little bit of time, but you can actually crank it out pretty quickly if you can focus through it. So let me kind of walk through it with you. We go here, we're under LabScribe, and then what we're looking for is that we want to open up the Bainbridge thing. So I'll open up one I opened up recently just to check it out before we started. Here, okay, now we've got this. And so what we have here is 2 EKGs here, and then this is our breathing part. And you can tell when the breathing started by looking at this, by looking at the bottom trace, usually. Sometimes they would have marked it, that's always helpful, but sometimes they didn't. And if it's really obvious, then it's not bad. But so let's see, I see deep breathing done here. So what you can do then is look at this deep breathing that happened between when they started the deep breathing and when it went back to normal. So let's do our deep breathing and choose 10 seconds out of this. And so we'll do it. So this is, we'll start here, end it there. There's our 10-second window. And so what we want to do is then go in between 2 cursors. There's our 10-second window, and then there's our deep breathing. So as we've talked about before in our in the class, there's a respiration that's important for being able to allow the breathing in and out of the respiration. Let me put it this way. What we are seeing is an influx of blood that comes into these, into the, oh golly, that's not showing pretty well. Let's exit out of here. So, what this is trying to depict, and if we could actually do the slideshow appropriately, what it would have shown is that you have the chest wall lifting up and the diaphragm moving out, and that drops the pleural pressure inside of the thoracic cavity, and that in turn permits the superior and inferior vena cava to move in. So the slides that we put up online will be able to show that. You can look through it on the actual slideshow itself. And so the key thing is just to realize that this is sort of a passive process in some ways, meaning that by dropping the pressure inside of the thoracic cavity, we're permitting blood to come in more easily into the superior and inferior vena cava. That stretches out the right atrium, and that in turn then causes the that causes the right atrium to stretch, and those stretch receptors then activate or send the message back up to the medullary cardiac control center, and then that suppresses the parasympathetic efferents, and the parasympathetic efferents then, since they aren't firing as much, your heart rate actually elevates. So these are all the components that are related to it. Okay, and you would have seen that. We talked about that in class, but just as a reminder. So now we see this here, and we've got this 10-second image that we want to generate, and we want to be able to mark out the instantaneous heart rate for each of the different cycles and put it into the Excel spreadsheet. What the heck does that look like? Here, what we can do is basically we pick out these different R waves. So an onset of an R wave here, for example, is cardiac cycle 1, here to here. So we can measure the instantaneous heart rate by looking at the interbeat interval. And so that's probably pretty good. And I'm just going to auto scale this so I can see it. And so that's my first instantaneous heart rate. And so that one, T2 minus T1, 850 milliseconds. So that's 0.85 millisecond, or 0.85 seconds. And so then I can just take 0.85 seconds divided by, 60 divided by 0.85 seconds and get what the instantaneous heart rate is. And so you can measure. What I would probably do is just get the instantaneous heart rates for this one, this one, this one, this one, and you can just crank through it pretty easily by leapfrogging it. So just write down 850 here, and then the next one here is 740. So it looks like there's that the instantaneous heart rate's actually increased a little bit there. It's gotten interbeat interval shorter. Here it is even shorter, so heart rate's even sped up even more. And then here now it's at 725 again as we start to exhale. And here it is at 770, and so it's starting to slow down, and it's starting to slow down some more. We can see it along this way. As you go through and continue to measure this for 10 different, for all the cycles that we have here, I believe they want it for all of the different cycles. Check here, take an image. For each cardiac cycle. Okay, yep, so we got to do all of those. And you'll have like a little list that you can keep, and then of all those interbeat intervals. And then what you're going to want to do is to go over here and to plot your cycles here. Cardiac cycles, you're probably going to have about 10. Usually people's, they're beating about 60 beats per minute. So do those 10, do at least the first 10 cycles here, and then be able to put in the instantaneous heart rate. So make sure you calculate that right. So if you remember, it was 0.85 milliseconds, which is, I'm sorry, it's so the way that you'd set it up is 60 divided by 0.85. That'll give you your instantaneous heart rate of 70 beats, so 70.5 beats per minute. So you'll want to do that for all of the different cycles that you actually have measured. Plot them into this graph here, and then that will populate this graph. And then what you can do is that you can take this, copy and paste it into your Word document to give you table 1. Table 2 here. Measure instantaneous heart rate for each cardiac to generate table 2. And report the average and standard deviation in the legend. Don't forget to do that. It's really easy to do and easy to forget. Figure 3 then is the brain image cycles here. What are they asking for? They're asking for that image that I was just pointing to over here. So in here, I want you to tell me which of the cardiac cycles corresponds to the onset of breathing in, inhalation and exhalation. So definitely tell me that, and then also indicate on here what the average heart rate is. So it's going to be, in this case, probably somewhere around here for 70 in this example. And what that does is that, or maybe a little lower, maybe like 65 or so. What this does is that this permits us to be able to appreciate how the changes around the average occur in response to breathing in and breathing out. And what you'll find is that it should match what you predict. And that's it's a pretty robust type of phenomenon that we see there. So that shouldn't be a problem. So go ahead and you'll want to be able to do that. All right, so then let's move on to figure, we talked about some of those figures. Let's move on to the Valsalva maneuver and talk about what's occurring in figures 4 and 5 here. So we want to generate an image of the Valsalva maneuver 3 seconds prior to initiation through 7 seconds to termination, after termination, and then measure the instantaneous heart rate for each cardiac cycle. So this is a lot, but we can do it. So take a look, go here. We'll open up a Valsalva maneuver, recent files, Valsalva, here we are, and here's our Valsalva. I'm going to zoom out. I'm just going to look at the entire trace here and see what we've got here. Well, obviously, it looks like the onset happened. You can see they're breathing normally here, and then something they're not breathing normally here. And also the size of the EKG waves drops, or actually the pulse wave drops precipitously here. And then the EKG density of the spikes here is much greater. So there's obviously a pickup in the heart rate in this case. So this is beautifully done, looks really nice. And so we should be able to monitor it. So the beginning of the Valsalva maneuver is right here. We can see that. So we want to do it about 3 seconds before that. So we'll choose that to be right. Move that over. Almost there, good. All right, and then we want this to be 7 seconds after it ends. So let's see what we have here. So this is where it ends, probably here. And so that's 220 seconds, so then we want it to be at 229. So I'll keep going out. Get close here. That's good. All right, so that's our window. I'm going to go ahead and just go between the two cursors to show the Valsalva maneuver. I'm going to auto-scale the bottom one so we can kind of see how this upticks here. I'm going to auto-scale the pulse wave so we can see that as well. And you can see some dramatic changes that are occurring here that correspond to these different pulses here. So each one of these you're going to want to look at the EKG wave and to get the interbeat interval. So like the Bainbridge reflex, we're going to go ahead and do this. Again, it looks really daunting, but you just get into a mode and you can get through it pretty quickly. T2 minus T1, that's 700 milliseconds. Great, write that down. Then you do this one. You can use the little arrow keys to kind of move it. You hit the next one. So that's about 635, and then you continue and go through. And so that first thing, your instantaneous heart rate, you can measure through your EKG. And maybe one of the leads looks really, noisy. You can use the other one if that works. And if that doesn't work, you could also possibly use your pulse wave as well. Just use the peak of the pulse wave to try to measure it if your EKG is not looking too hot. Then what you can do is correspond this to the different phases. You're gonna, in your figure, you're gonna want to indicate where is phase 1, where is phase 2, and everything like that. So phase 1 is right at the onset of the pressure. So you're gonna see that there's going to be a detection of, oh wow, I've got a lot of pressure that's building up here. I'm going to need to be able to slow down a little bit, and so they'll change the heart rate accordingly. And then what happens is it accelerates, and then we see the different types of changes that occur after you have the release here of the pressure, and release of the pressure causes a moment of increase firing, and then an increase in your heart rate, and then finally what happens is that you have the heart rate slows down quite a bit as the blood starts to reach your baroreceptors in your aorta. So this is a really nice trace that we have here. This is a little bit noisy, so that might be hard to read, but this isn't bad at all. So you want to go through and capture those. This is a lot, but you can do it, like I said, if you, just write them down real quick. Here's the cardiac cycles listed here for you, so it's estimating that you'll have about 28 of them, and then the instantaneous heart rates, you'll plug them in, you'll get your figure there. And then so for that table they want, you can just copy and paste this, report the average and standard deviation, and then here you're going to want to copy that and paste it into your Word document. So what that'll do is give you your figure 5, which is your graph that you're showing here. And oh, you don't have to make a table for the Valsalva. That's nice. So the only thing you're going to have to include is your figure 5, which is this guy right here, your graph. There, you won't have to include this table. Okay, so then going back then, let's go back to our Word document. What do we have left? Talk about what's going on here and go through all those different details. Figure 6, heart sounds and pulse pressure. Let's talk about that one real quick. Over here, we have file, open, recent files here, and we've got heart sound and this part. Okay, so in this case, what we're looking at is that we want to measure the pulse wave velocity. We're going to look at the onset of the R wave, so those are our top 2 traces, R wave, auto scale this. Then we want to look at our pulsed wave, which is this guy right here, the green one. And so we can look at that and say, okay, well, when is it that we went from the onset of the R wave to the onset of the pulse wave? And that gives us a sense of how much time it took to go from when our heart depolarized, and presumably when the contraction began, and then when we actually start to feel the pulse pressure wave appear in our fingertips. And that speed is affected by the elasticity of our cardiovascular system, and so it's very useful. So that's our T2 minus T1, and that's how we can measure that. When we're asked to find out about, let's see if they're, sound 1 and sound 2 and all of those things are depicted down here, and so you can look at the R wave and then see which is the closest sound that corresponds to sound 1 or sound 2. And so you can do that labeling accordingly as well. Let's see what they want us to be able to generate here. So 5-second image with the ECG, 1 lead only. Okay, you can have 2 leads in there, I don't care. Pulse pressure and heart sounds, that's what we talked about. Identify S1 and S2 and 2 cardiac cycles. Determine the velocity in centimeters per second. So to get the velocity, the second part is really easy because we just measured that, right? That's from here to here. So that's 210 milliseconds, which is 0.21 seconds. But the centimeter part, where do you get that? That's your measurement that you took in class from the sternum out to the end of your fingertip, your extended fingertip. And that gives you an idea of the distance that the pulse wave had to travel to get to reach the pulse transducer. All right, great. So now we've got that figure 6 lined up, and then we can go through and answer the questions here. So hopefully that'll help you be able to navigate some of the questions that we have for, or get generating the figures at least for the report for the human ECG. Thanks for your attention. Hope things are good, and I'll get back in touch with you later.